Professor Ute Roessner grew up in East Germany. She was 17 when the Berlin Wall came down.
I will remember it like it was yesterday on our first trip to West Berlin. We just crossed the border and there was a lot of business. West Berlin selling bananas and all the things we East Germans didn't have. So we took the first bus which came by and it took us to the rich area of West Berlin. And I remember people sitting on the floor begging for money. That did not exist in East Germany.
She studied nursing in a hospital as part of her dream to become a doctor. But a few weeks in, she knew medicine wasn't right for her.
It's a tough job. I took every patient home with me. I was worried when I left the hospital what happened for the other 16 hours until you're back for the next shift. And I thought I just couldn't be a doctor.
She still completed her 3-year nursing course before shifting focus to biochemistry at the newly founded University of Potsdam. Not long after, the Max Planck Institute for Molecular Plant Physiology moved to the campus. She knocked on the door asking to be an intern and was soon conducting analytical measurements of single metabolites, small molecules, such as glucose and fructose. Each metabolite had to be measured individually, which was slow and laborious work. But then the institute purchased what Professor Roessner describes as a new toy, a gas chromatograph coupled to a mass spectrometer which had the potential to measure all those metabolites in one go. She was invited to do her PhD on developing the best ways of using the instruments to study plants.
The most significant contribution, and it was a team effort at the Max Planck, was to develop those technologies in the biological sciences and get the community to understand the value of those new technologies.
It was pioneering work which helped establish the field of metabolomics, the large-scale study of small molecules. Thanks to her original research, metabolomics is now used across multiple disciplines, including plant science, biomedicine, food chemistry, and microbiology.
So across the globe, many institutions then bought the same instrumentation and adopted our methods very quickly.
In 2003, Professor Roessner emigrated to Australia to create a metabolomics platform for the Australian Centre for Plant Functional Genomics at the University of Melbourne.
Being invited to set up a metabolomics facility in Australia was a huge opportunity because I knew I was the first one here to do it. I could purchase the right instrumentation. I could build a team who for Australia set up this platform.
A platform used by plant scientists across the country. After 18 years in Melbourne, during which she ran her own research program, Professor Roessner recently made the move to the Australian National University in Canberra. Her research uses metabolomics to increase a plant's climate tolerance and fertilizer intake, not only improving agricultural yield, but reducing the environmental impact. Her latest project is aimed at better understanding how plants interact with soil microbes.
My biggest question no one yet could answer is how a plant recruits those bacteria or microbes which are beneficial as opposed to those which are pathogenic, which they repel.
Professor Roessner says she's proud and humbled to become a Fellow of the Australian Academy of Science and hopes it inspires others to study what she calls the wonderful world of metabolomics.